At TRD, we're involved in motorsport throughout North America. So as part of that, we're building a whole series of cars based on the GR86 that we're going to run in what's called a single make series. 3D printing has had a big impact on TRD, both in the design and development of all of our chassis, but also in the low volume production of our GR86 Cup car.
We use additive manufacturing at TRD USA for rapid prototyping of different applications, and we also use some of those applications for direct production parts. We use FDM and SAF.
We've actually moved into production on some of the hood vents, the door handle surrounds, the air intake vent for the engine. Previously, we would have solved those problems by using composite materials. The related expense and time that would have been involved in the tooling of those would have led to higher part costs and really not as tightly integrated into the chassis in the car. We had to operate on a really compressed timeline. So being able to do 3D printing was a pretty big time save.
This is one of the SAF parts we use on the GR86 Cup. This is the interior door handle bezel. The SAF technology allows us to nest a lot of these parts in one print and get a lot of production in one go.
One of the key elements that we were able to really get good development activity around was the hood duct that we were able to print in several different ways, different volumes, different sizes, to get the underhood temperatures under control.
So this part right here is the fresh air intake on the GR86 Cup, which is printed on the F370 CR machine using nylon CF10. Using 3D printing is really conducive to this type of part because this is going to be a laid-up carbon part or injection molded part. You'd have to purchase the tooling associated with this part. And when you get a 3D printer, you've purchased the tooling not only for this part, but all the future parts you decide to design on it as well.
3D printing has had a big impact at TRD. It allows us to iterate very quickly. It allows us to solve problems in a tighter time window and really has driven our costs of development down.
3D printing has also helped TRD with design consolidation, so parts that would normally take multiple tools or multiple inserts or tooling that is expensive, we can consolidate all of that with 3D printing and make one part that could have been potentially 3 different tools we can now use with a 3D printer. The F370 CR's throughput helps us meet our stringent timelines without sacrificing any dimensional quality. It's a very appliance-like 3D printer. I've used a lot of different 3D printers in the past, and this is the easiest one I can say as far as the HMI and the printability. The dimensional stability is very good. Whenever we're printing parts on any of the Stratasys machines, they come out and they fit.
The performance of Stratasys products has really allowed us to integrate really high quality products into the design of our cars. And it really leads to the targets that we're trying to make for the quality of the GR brand.
Being able to design a part and then bring it to manufacture, depending on the size of the part, sometimes even same day, it allows us to do a lot more fast-paced design. And in the racing industry, that's absolutely required to stay competitive.
Toyota has a reputation for high quality, and partners like Stratasys allow us to achieve high quality.